All right, let's put on our detective hats today. We're diving into a really cool mystery, but it's not a crime scene. It's a data set full of pumpkin prices. And our job is to crack the case using one of the most powerful tools a data detective has.
So here's the big question, right? When you're looking at a whole bunch of information, like say pumpkin prices and the time of year, how do you actually know if they're connected? Or is it just a coincidence? Well, that's exactly what we're going to figure out.
The main tool in our detective kit for this investigation is something called correlation. You can think of it like our magnifying glass. It lets us zoom in on two different things in our data and see if there's a hidden pattern, a clue that links them together.
So, what exactly is correlation? In simple terms, it's just a number that tells us how much two things change together. You know, when one thing goes up, does the other thing also go up? Or maybe it goes down. That predictable relationship is what we're searching for.
And you can actually see the clues pretty clearly. If we plot our data and the points form a nice, tight line, well, bingo, we've found a strong connection. That's high correlation. But if the points look like a random cloud, just scattered all over the place, that's our clue that there's probably no relationship, and we need to look elsewhere.
To get really precise, we measure this on a scale from -1 to +1. Think of it like a strength meter. A number close to +1 means you've got a strong positive link. When one thing goes up, the other tends to go up too. Close to -1, that's a strong negative link. One goes up, the other goes down. And a number right around 0, that tells us there's pretty much no connection at all. So, for our case, we're hunting for those numbers close to 1 or -1.
Okay, time to open up our case file. We've got a ton of data on pumpkins. Their price, when they were sold, what kind of pumpkin they are, you name it. The big mystery we need to solve is, what is the one thing that can actually predict the pumpkin's price?
So, who's our first suspect? Time seems like a good place to start. I mean, it makes sense that pumpkin prices might change depending on the month, right? Maybe they get cheaper the closer we get to Halloween. So, first things first, let's plot the month against the price and see what happens.
And nope, it's a dead end. The correlation score is basically 0. And if you look at the plot, it's just that scattered cloud we were talking about. So it turns out the month of the sale has almost nothing to do with the price. Bummer. Okay, one failed attempt isn't going to stop us. Any good detective knows you have to keep digging. Maybe looking at the month was just too broad. Let's get more specific. What if we check the exact day of the year, from day 1 all the way to 365, and see how that relates to the price? Now, this feels like a much better lead.
And another swing and a miss. Even with this more detailed view, the correlation is still pretty much 0. We're looking at another scattered mess. It kind of feels like we're back at square one, but honestly, this is a super important part of being a data detective. Your first few ideas often don't work out.
But wait, just when you think the trail has gone cold, something interesting starts to pop out. The data might not be in a straight line, but it's not totally random either. If you look closely, there's a hidden pattern in there, just waiting for us to spot it.
Take a closer look. Do you see that? It's not just one big messy cloud of dots. The data seems to be clumping together in these weird little groups, or clusters. Now that is an anomaly, and in any investigation, anomalies are usually where you find your big breakthrough. So what could these clusters possibly mean?
This observation sparks a brand new idea, a new hypothesis. What if we've been looking at this all wrong? What if we're mixing a bunch of different kinds of pumpkins together? Maybe each of these little clusters is actually a different pumpkin variety. And that's the missing piece of the puzzle.
And that's it. That's the aha moment. As the original analysis notes, it does seem that there's some truth to our hypothesis. We can see it with our own eyes. The pattern suggests that different types of pumpkins are playing by different rules. We are definitely onto something big here.
All right, we've got a hot new lead. Now we just have to prove it. It's time to follow this clue and see if we can finally crack the case wide open.
And here it is. The proof is right here in this bar chart. It's showing the average price for different kinds of pumpkins, and it could not be clearer. Pie-type pumpkins are consistently cheaper, and miniature pumpkins are way more expensive. Our hunch about those clusters was spot on. So this gives us a totally new game plan. We can't just lump all the pumpkins together. That was our mistake. It was just muddying the waters. So let's filter our data and look at only one type, the pie-type pumpkins, and run our correlation test again between the day of the year and the price. And check this out. This is the breakthrough.
The difference is night and day. Before we filtered, the correlation was worthless, almost zero. But after we isolated just the pie-type pumpkins, the correlation is suddenly much, much better. We found the hidden relationship.
So we did it. We found the hidden variable, we proved our hypothesis, and we uncovered a real correlation. Case closed, right? We can all go home? Well, not so fast. Like in any good mystery, there's always one last twist.
I mean, it's way better for sure, but it's still not a perfect -1 or a perfect 1. The relationship is definitely there, but it's not what a data scientist would call an amazing correlation. The line isn't perfectly straight, you know?
And that leaves us with the final million-dollar question, doesn't it? We found a real connection, but is that connection strong enough to actually build a tool that could reliably predict what a pumpkin will cost? That's the next step in the investigation, and it's a question every single data detective has to answer for themselves. Thanks for joining the investigation.